Welcome to ml-gradle Episode 4, Securing Content from MarkLogic University, Roles and Permissions. This first part begins the topic of deploying security with ml-gradle. To follow along with this tutorial, you'll need to download and install MarkLogic. You must also have installed Java version 1.8 or higher and the latest version of Gradle. Gradle downloads all project dependencies, including the ml-gradle plugin. In the build.gradle file, we define the ml-gradle version as 3.7.1. This version, or later, should work fine for our examples. Download the tutorial files and follow the installation instructions in the tutorial README by going to github.com/marklogicuniversity/ml-gradle-series. In this video, you will learn how to use ml-gradle to configure users and roles, load content with permissions, and test document-level permissions. MarkLogic implements a role-based security model to control who can read, update, and delete your content. Users must have at least one role in order to do anything in the system. MarkLogic controls access to document content with a combination of roles, privileges, and permissions. Privileges control who has access to certain MarkLogic code functions, or what URIs can be created. Permissions combine with roles to permit users read access to documents in MarkLogic databases, update content within documents, and execute application code stored in module databases. Users can be assigned multiple roles. For example, in our Star Wars character application we started in the ml-gradle Episode 3, we might choose to have separate roles for who may read or document data versus who may update that data. MarkLogic's admin role has full authority in the MarkLogic system, making that role very powerful. In reality, few users need to be all-powerful admins. Since Gradle, with the ml-gradle plugin, enables us to easily create and update these roles, we can define our security early on in our application development, then easily adapt as our security needs become better understood. Defining security early on in development is a best practice and promotes the idea of defining our security model towards the beginning of a project rather than towards the end. To begin securing our Star Wars character application, we've chosen a base security model that will create a specific content read role called Star Wars-Reader. The Star Wars-Writer role inherits this reader role to read and also update documents. A specific Star Wars admin role inherits the Star Wars-Reader role and also the Star Wars-Writer role for users that need even more privileges in our application without needlessly assigning them to the all-powerful admin role. In our example application, we relied on a user with the admin role to load our documents into our example database and to read that content. In this iteration of our application deployment, we'd like to take advantage of users and roles to be mindful of who has access to our content and who can update that content. We are creating some users based upon our Star Wars character example data. Lorth Nita is an Empire fleet officer who needs to read content pertinent to Empire matters, but not necessarily have access to content that is related to the Rebel Alliance. Likewise, Luke Skywalker should be able to read Rebel Alliance related content, but does not need to update that content nor have access to Empire Alliance related documents. Darth Vader and Princess Leia are both leaders in their respective alliances. Therefore, they need more than read access to content. Additionally, as leaders, they both need access to both Rebel and Empire information. We'll build on our security role model to extend the Star Wars-Reader and Star Wars-Admin roles. We'll create two new reader roles, Empire-Reader and Rebel-Reader, to protect, read, and search access to our content depending upon the user's alliance. We'll also create an Empire-admin role and a Rebel-admin role, which both inherit from the Star Wars-admin role. This will permit read and update permissions to our content. Each admin role will inherit both Rebel and Empire read roles to ensure leaders of both alliances can search all of the content. ml-gradle stores roles and users' resource configuration files in the security subdirectory. Roles can inherit other roles. For example, a role that can update content must also be able to first read that content. Our example application uses Star Wars-Reader and Star Wars-Writer roles. The Star Wars-Writer role inherits the Star Wars-Reader role. This might be an issue if we attempt to create both roles in the same transaction. The Star Wars-Reader role wouldn't actually exist in MarkLogic before attempting to create the Star Wars-Writer role. ml-gradle enforces this ordering of operations with a two-pass process. Pass number 1 sends all role configurations to the MarkLogic server. The second pass sends only role configurations that have a dependency on other roles to ensure roles inherit correctly. This process means that file naming sorting order isn't needed to ensure that roles are deployed as desired and has been in place since version 3.2.0 of ml-gradle. Note, if you're using MarkLogic's Data Hub framework, the project directory structure is different than the standard Gradle type structure used by ml-gradle. In the Data Hub framework, MarkLogic's security roles and users are defined in the hub-internal-config directory structure. Document permissions secure content in a MarkLogic database. Permissions combine a role with a capability and stored as metadata with each document. Only users with the admin role can access, update, and delete documents that have no permissions. Permissions apply not only to documents, but also to indexes for those documents. If you cannot read a document, you also have no access to the indexes for that document and cannot search content in that document. Permissions can be assigned to documents while loading and can be updated after the documents are stored in databases. MarkLogic offers different methods of loading data depending upon the use case. All of these approaches to loading content can apply permissions. Note, if you apply permissions after the content has been loaded into the database, that content will have to be reindexed. The ml-gradle plugin can utilize MarkLogic Content Pump Java libraries to quickly load file-based documents to MarkLogic databases. Permissions are applied while documents are loaded. If no specific permissions are specified, the default permissions for the user executing MarkLogic Content Pump are used. In the ml-gradle plugin, Gradle properties and/or MarkLogic Content Pump options define the user that loads the content. MarkLogic Content Pump, or MLCP for short, is frequently used to load various document content to MarkLogic databases. ml-gradle can access the MLCP's Java libraries, then use Content Pump directly from a Gradle task. We can pass in all the Content Pump options that we'd like by adding them to a customized Gradle task. To call MLCP from Gradle tasks, we need to change the build.gradle file to download the MLCP Java libraries from a repository. Then, we need to tell Gradle that these are dependencies for our project to resolve. We also need to create a Gradle task in the build.gradle file. We've created an example task we called Deploy Content. This is a custom task deriving from an ml-gradle task type of MLCP task. In this task, we use the same MLCP options to accomplish our desired results. In this example, we're importing documents from two directories, one for Star Wars character data and the other for Star Wars image files. This is what we also did in the ml-gradle series episode 3, However, in Episode 3, we used the admin user with the admin role. Our content was only accessible by those with the admin role. We'd like to move towards a better practice of specifying specific roles to load our content and specify permissions for those that will interact with our content. The username and password for loading our content will be the values of the ml-manage username and ml-manage password in our gradle.properties file, our stores-admin user. In ml-gradle, these represent the user that has the REST admin privilege and permissions to effect changes to configuration and also inherits the REST reader and REST writer roles. These are enough permissions to load our content. Without specifying permissions for our content, the default permissions for the stores-admin role will be used. But these default permissions are too lenient for our initial test. We'd like to be a bit more specific who can read our content versus who can update our content. So we are applying specific permissions to these documents so that any user with the REST-reader role can read our content, search it, and access indexed values. Users cannot change or delete any content unless they also have the REST-writer role. Since the Star Wars-reader, Rebel-reader, and Empire-reader role all inherit the REST-reader role, Luke, Lorth, Leia, and Darth Vader will all be able to access and search our content. To follow along, download the ml-gradle series project from MarkLogic University's GitHub repository. After downloading, open a file browser or command line and change to the Episode 4 folder. Then change to the Part 1-roles folder. Copy the Star Wars project folder within the Part 1-roles folder to the Episode 4 folder. Open a command line or terminal window, then change to the newly copied Star Wars project within the Episode 4 directory. Redeploy our Star Wars character application by typing gradle -i ml deploy, then press enter. With the application deployed, we then run the command gradle space deploy content, then press enter. This runs our MLCP task, loading our content to our database using the default permissions for the Star Wars admin user account defined in the ml-manage user property setting in the gradle.properties file. We've changed the application a bit since Episode 3 of the ml-gradle series. Now, you can log in as a specific user and log out again. This will help test our security and roles. We navigate to the URL of http://localhost:9010/login.xqi in our browser, and our application server now displays a login page. In our discussion of users and roles, we have defined 4 users to test permissions. Darth and Leia are users with the roles of Empire-admin or Rebel-admin. They need more permissions. Lorth and Luke have the roles of Empire-reader or Rebel-reader users. They need access to our content also. We log into the application using the username of Leia and the password of Leia, which is one of our deployed users. In our security and roles, Leia is a Rebel-admin role which inherits from the Star Wars-admin role and includes the REST reader role. All of the documents that were loaded with our deployed content ml-gradle task have the REST-reader role and the read capability. Since all of our users that we created also have the REST-reader role, any of our Star Wars users have access to the information. The Google charts have been arranged to display more columns in the Google chart table. The column chart of height values now appears below the table. The MarkLogic University On Demand site has an excellent security series to learn how MarkLogic implements security. See the full security episodes at mlu.marklogic.com/ondemand. Learn more about deploying security with ml-gradle by visiting the ml-gradle GitHub site and the ml-gradle wiki at https://github.com/marklogic-community/ml-gradle. In this episode, you learned about using ml-gradle to configure users and roles according to a desired security model, load content with permissions that secures the content to specific roles, then test document-level permissions. To get MarkLogic, download from developer.marklogic.com. Get more training by visiting marklogic.com/training. Also, a complete selection of on-demand topics is available at mlu.marklogic.com/ondemand. Or download the MarkLogic mobile app available on both the Apple App Store and Google Play. And don't forget to show off what you've learned. Add MarkLogic as a skill on your LinkedIn profile today. Thank you for watching this MarkLogic University On Demand tutorial.